Hello there, ladies and gentlemen, and welcome to another video. Now, in this video, what we're going to be doing is we're going to be trying to set up QMK so that, for example, this keyboard is able to send instructions to this trackball. Because as you can see right now, this version of the trackball has no buttons or anything. And I want to be able to use the drag scrolling like on the Ploopy trackball. So what I want to do is I want to press a key on my keyboard, and while holding that key, if I were to move the trackball, instead of moving the cursor, it will actually scroll the screen. So like this instead. And so for that, what we need to do is we need to use QMK's raw HID feature, which would mean is that the keyboard will send some data to the PC, and then the PC will send some data to the trackpad or the trackball, and we'll need to write a program on the PC to kind of act as a router between those two, sort of. So yeah, that'll be kind of interesting to do. So now that you guys know what the fuck is going on, I can hide all this stuff. And so here we have some setup. Here we actually have the macro pad instead. So just in case this raw HID messes up something, I don't want to mess up my keyboard. So I'm going to actually use my macro pad. Now the macro pad is also running QMK, so that's fine. Pretty much everything you see here except this thing is running QMK. So yeah, I'm a big QMK fan, as you can probably tell. Yeah, so this is updated to the latest QMK pretty much. Now this next here is going to be our program, so I just called it QMK raw HID router. And now the last thing here is our trackball. So this will be the one that's receiving commands, but it can also send commands if we wanted to. So I did a bit of digging around. So if we go to QMK raw HID, here we go. So yeah, it's fairly straightforward. So I didn't enable any of this thing yet because I want to kind of show you guys some stuff. So here, let me actually make this a little bit bigger. Yeah, like this. So here we're using Python script. So to set this up, what you need to do is you need to install the pyhdipi blah 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 library. You can either use pip install, or if you're on Arch, you can use pacman-s python HID. You also need the HID API. This is actually the C API underneath. So when I'm kind of finished this, I'll probably rewrite this in C because it'll just be, I don't know, kind of easier, I suppose, than having Python, because then I can ship kind of you know, just raw binaries and then you can use those. But yeah, with Python, you need to like download Python, you need to download libraries, you need to download a bunch of fucking bullshit. So yeah, but it's easy. It's like, you know, quick to test stuff with Python. So that's what we'll be doing in this video. Yeah. So here, anyway, I had a quick mess around, and what I did is I printed all of the USB devices that are on my PC. So if we run this actually, so before we do that, we only want to show kind of the QMK devices because I do have a lot. So if device, and we'll just copy this manufacturer string, equals, and so in all our cases the manufacturer is just my name. So yeah, for all these, so this should only show the kind of QMK devices, and we just want to append the list if that's only the case. So if we were to run this, Okay, so as you can see, we have kind of 3 different devices. Yeah, so we have this guy, and yeah, so the trackball, it has two. It has let's see, 1, 2, 3, 4, 5. It has 6 for some reason. We have the macro pad, which also has 6 for some reason. And then we have this thing, which also has 3. So that's the keyboard. Okay. So in this case, this isn't actually showing up in bytes, which we kind of need to, because if you look at here, VID, it should match these bytes. So let's see if we can print this shite in bytes. So actually, I wonder if I were to print normally, would it show? So we also need this thing here. So this is just without using the table. So you'll see that the table is, quite pretty. But if we were to do it like this, okay, so it still shows these like that. So what I need to do then is I need to figure out how to print hex in Python. So let's see. Python tree print hex. Yeah. What the fuck? Okay, so there is a hex command here. So let's try that. So hex, or hex function. So we only need this and then the usage page as well, but let's see if that actually does what I needed to. And okay, so this is the track. Yeah, so that looks right. So as you can see here, 9000 VID, and then PID is 9001. Then if we go to the macro pad, it is 445D, and there we go. And then the PID is 3538, and there we go. Okay, so that's pretty good that you can actually do this. So that's good, it makes it nice and easy. We also need to hex this thing, and we also need to hex this thing, and we also need to hex this thing. Okay. Right, so in this case, actually, we will need to hex this thing too. So just for consistency. Manufacturer, that's fine. Product, usage page. And usage. Interface. Yeah, then I think I hexed this thing as well. Okay. Yeah, okay, cool. So if we were to print it normally, let's see, how does it look like? Yeah, so that looks good. Okay, cool. So, yeah, so the usage pages are actually sort of important. So yeah, this is kind of difficult to read, so I'm just going to go back to the print in table. All right, there we go. So yeah, that looks good. So what we're going to do is we're actually going to copy all of this thing, and we're just going to save it. I'm going to create a new folder, just before txt or something. All right, so this is what it was before. And then, right, then what we're gonna do is in here, in the, what you call it, in the trackball, we're gonna start enabling this raw HID thing. So, I think I can just do raw like this. So, raw, true. And then we need to also raw usage thingy and this thing. So we need to define these inside the config.h. So put those here. Define. So actually we need to make sure that there is no kind of usage page that's using FF60. And from what I can see, there isn't. They're all fairly low, which is good. And then usage ID, which is here. We have 81, but yeah, there's no kind of 61, so that's good as well. So we'll use the default kind of stuff that QMK recommends. So that is fine. Okay. All right. So yeah, that should be good now. So when we rerun this thing, we should see this again. But first, we're gonna need to compile it. So to compile it, I just do this. Let's see if it compiles okay. And let's see if we can see anything for raw HID being included. Actually, yeah. Yeah, I'm not sure if that actually worked, but we'll try it. So I'm gonna unplug this thing and I'm gonna plug it back in while holding the boot button so that it mounts on the computer, because this is using Raspberry Pi Pico. And so now we are back, and if we run this thing again, okay, so that seems to have worked. So as you can see from the usage before, it wasn't there, but now this new feature is there. So the new thing that we created here. So that's good that it works. We can do the same thing on the what you call it, the macro pad. So we will enable the raw feature, raw true, and then inside the config.json we will set these two here, like so. Oops. Okay, set them like here. And then what we can do is we can compile this thing. But I kind of forgot what the compile command is, so I need to check my key map. Okay, so, okay, got it. So, yeah, this one's a bit easier since it has macros. So that one was, yeah, so the flash was here. Okay, there's a bit of a fuck up. Let's try that again. Huh. Okay, there is something weird going on here. Fuck it. All right, and then I will boot it into QMK or into a bootloader. So this one's easier again, I just need to press a button. Okay, so now we are fully flashed with the newer firmware. And let's see if the macro pad has it. Oh yeah, there you go. So yeah, the macro pad has it as well. Epic stuff. So now what we need to do is first of all, we need to grab these IDs like so for both of them, but first we'll just try it out with actually we'll try it out with we'll try it out with the macro pad first. So if we head over here, to send the data you need to use all this kind of stuff. So inside QMK there is this function here, HID receive, right? And and then you can do raw HID send, but we won't do that yet. So we'll just copy this whole thing here. I don't think we need to include anything. I don't think we need to include anything. So we'll just do it inside the key map. Although there is kind of a lot of stuff in here. So in that case, I will actually create a new function or a new folder called raw hid.c. Actually, this might conflict with, no, fuck it, this grand. I am going to include my usual includes, which is just the shared defines, like so. And we also need to add this new full file, Jesus. So this will be raw hid.c, like so. So that should compile with this new file. And so we're not gonna do any of this stuff. All we're gonna do is we're gonna check if something arrived. And the easiest way to check is by just simply doing something like this here. Where is this thing? So we'll just do a big send string. So this will just, the keyboard will just type out some stuff. Okay, so got some stuff from raw HID. So that will be like that, I suppose. So got some stuff from raw HID. Let's see if this compiles. Okay, seems to be compiling, so let's flash it. Okay. So now we're running the new firmware, which should accept those things. So I'm actually just gonna remove this thing. Delete this thing. Okay, so here, right. So we'll need like a new function here. So something like this. Something like this. So we will create a new function here called, let's just call it, I don't know, test. Right. So it'll be like this. Now we have all this shite here. Oh, what the heck. Okay. So usage page is going to stay the same because that is the usage page that we're using here. So that's going to stay the same. Report length must always be 32. So if you read further along here, where is it? There it is. Okay. All reports must be exactly raw EAP size, which is currently 32 bytes long, regardless of the actual payloads. Okay, so raw EAP size, excellent. Okay. Well, anyway, for the VID, the vendor ID, we have 44. And by the way, you can change this to whatever you want, just as long as it doesn't conflict with anything else. And then the PID is 3538. Okay, and then the rest is the same shite. Cool, so, right. So then he goes through the interfaces. Then interface is going to be the path. Interesting, okay. So he uses the path actually. Okay, that's fine. And then, okay. Cool, so. So you can actually just literally do this. Okay, that's cool. Okay, so. In this case, all right. So device interfaces, yeah, we'll go this as a KB or something. KB, because later on we'll be using another, for the other thing as well. Yeah, so usage page equals that. Okay. So next thing is if len is equal to that, what we're gonna do is we're gonna do a print. And it's gonna be could not find KB interface exit G. Then we're gonna do exit. I think you can do this in Python. I'm not sure. Python tree exit. Come on, DuckDuckGo, come on. Jesus. Okay, is there exit? There is. But can you pass something to exit? Like a number, like in C. Okay, so you can do os.exit, okay. Let's do that. Okay. So import os, you don't need to download this. So then os.exit, I think is how it goes. Right. So let's actually just fucking try that straight away. See if that works. So we don't need to print the table anymore. We can just do test right, like so. What the heck happened here? Device interface is not defined. Oh yeah. Okay, well, device interface is KB. Okay, let's try that again. Okay, yeah, so it does support exiting properly. That's good. So if I were to change this to, oh yeah, this thing to 2, then if we ran the script again, as you can see, we have now an exit, an exit code of 2. We can also do it like this. So yeah, here's an exit code of 2. So that's pretty cool. So good, that works. So if we could not find, it prints that. Okay, so next thing is we need to do this. So we actually need to get the interface of the keyboard. So this will be interface KB, and this will be KB 0 path. Yeah, because wait a second. Oh yeah, no, yeah, it's fine. Yeah. Okay, so yeah, because this should be the only one here. So yeah, that makes sense. Okay, so interface KB. Right, so we got the interface here. Now, what we need to do is we need to send some data. Now, there was a handy padding function that I seen here. Not that one. Let's see here. Yeah, pad message. If your board uses 32 byte. Okay. Here we go. So we will just steal this function to pad the message. Right. So this, yeah, fuck it. 32. Okay. So probably uses 32, I don't know. We'll just fucking have a go. Actually, yeah, raw heap size for Raspberry Pi Pico. We can just Google that. Raw heap size for RP2040. Huh. Okay, so there is no fucking documentation at all, it seems like. Let's try Google. Aha, so there is something here for RP2040. Let's see. So, raw heap size, okay. Aha, I see. So ChibiOS, this thing uses 32 and 64 on AT SAM, whatever the fuck that is. Yeah. But yeah, we don't have this fucking, we don't have the 64-bit one, so that is fine. Okay, cool. So how does this guy pad the message? So he pads the message with, right, then the data. So we also need to find send. Yes, okay, here we go. 2 bytes. Ah, okay. So that is pretty straightforward. So he just does it like this. Okay. And QMK, how do they do it? Raw HID, they do it also like that, and then bytes. Okay. All right. Where is this fucker? Okay, so he does it just 2 bytes like this, and then he pads that data. Okay. That is fine. So we can actually just do fuck. God man, I fucking hate this this shite. Okay, here we go. So, right, so we got the HID device. Now we want to create some data. So this will be data to send. And this will be pad message. And then there'll be 2 bytes. And I am pretty sure we can do something like, let's see, 0x, I don't know, 0, 1. So that's 1 byte. Yeah, this is gonna be 0x. Or is that how you, yeah, that is, yeah, okay, 0, 2, 0x, 0, 3. Okay, so then it's gonna create that thing. And then what we need to do is, we need to do something like this. Interface.write. We don't need to read anything. Or maybe we can, I don't know. Well, we won't now anyway. Right, so yeah, data here. right, whatever. Okay, so we can try do that. This will be data to send. Yeah, interface is actually going to be KB. Interface KB, but we won't actually read anything here. And yeah, we'll just say print sent stuff successfully. Jesus. Then here we can do print failed to send stuff successfully. Yeah, okay, so that should probably be fine. So now, oh yeah, actually this is going to be a bit weird since this is going to type into here. Well, fuck it, I'll just fucking run it. Okay, so what happened here? Raw HID interface not defined. Okay, yeah, so I kind of messed up there. Yeah, raw HID interface is KB. Okay, so let's try running it again. Okay, so test write. What happened here? Unable to open device. Interesting. Okay. Okay. Right. Let's see what thing you're actually trying to use. So print. We'll do an F string. So trying to open. Then we will put this here. Actually, we don't need this thing in this language. We don't need this thing. And that should be fine. Okay, let's see what happens now. Okay, so we're trying to open dev HID draw 7. And let's see, is that correct? So let's actually print the table first. Oh yeah, we actually don't display the path, which we should. So when we print device info, we should also print the path, but I kind of forgot what that looks like. So if we go to print normally, let me print device. Actually, print device. Okay, and then here we will print normally instead. Okay, so this is okay, so it's just literally called path. Okay, that is fine. So we can do print in table. And then, so we'll do a device path, like so, and then this will be path. And then that should print the whole table nicer. Okay, so we're trying to open HID draw 17, which is the correct one. But yeah, for some reason it's not allowing it. So let me try running this as sudo. And let's see if that's actually the problem or if it's something else. Trying to open. Okay. So it was something else. Right. Okay. Now we have a different problem. The byte. Okay, so I think it's just bytes. Yeah, okay, so here we go. Where is this fucking shit? Okay, so get rid of this thing and just say bytes. Oh, nice. So look at that. Wait, some shit happened. Failed to send stuff? Sent stuff successfully. Failed. Oh, right. Yeah, because this is finally. Never fucking mind. We need to catch as well, I think. That should be a thing, right? No? Huh. Okay, let's see. Python tree. Python tree try catch. Yeah, I'm not really, so it's accept. Okay. Accept. So this will be print failed to Jesus, right. Shit. Now I wonder actually, does this give an error? No, it doesn't. Alright, well, fuck it. Goddamn Python. Anyway, so that's fine. Yeah, so basically what this means is we're gonna try opening this stuff. If something goes wrong, it's gonna print this message, and then finally, after everything is done, it's just gonna close the interface, which is what we want. Now, the thing is, I don't want to run this as root, but it actually works. So yeah, as you can see, we got some stuff from raw HID, which is what we programmed here. So this thing actually received just fine, which is good. And it doesn't look like it crashed or anything. So that is good too. Oh, my bad. So it actually never closed it. Interface KB close. Okay. So, right. Cool. Right, so in this case, what we actually want to start doing is, well, first of all, I want to figure out why when I run this as root, or without root, I mean, it's unable to open device. So if we go into here, so save that, reload rules, and then suppose trigger, and I suppose we can. Oh my god! Man, I fucking hate this shit. I fucking hate this shit. But finally, we actually got it working. So you actually needed to do that. Then inside the file, just put in. Oh my god. Just put in this. Okay. Cool. Jesus. We got there in the end. That's good. We have finally have it working without root. Great. Holy shit. Now we can actually continue this shit. Right, so next thing we need to be able, we need to be able to parse this shit. So right now we're just sending willy-nilly fucking shit. We're sending bytes. So in here, what we need to do is we actually need to be able to, do some shit basically. So, right. Okay, so we have data here and we have data length. Okay. So now what we need to do is we need to do something. We need to check something like this, basically. Yeah. So data is of size this thing. So what we can do then, if data 0 equal to x 0, 1, if I did 5, 5, what is that? Ah, excellent. Okay, so if equals got 0, 1 in HID. So else if data 0 equal to 0x, yeah, fuck it, 1, 1 doesn't matter. Then we can do send, yeah, because this thing is basically, yeah, so it's 8, so it's 4 and 4. Yeah, okay, whatever, fuck it, that's what it is. So got 1, 1 in HID. Or actually, it'll be interesting if it was like this, 1f, got 1f in HID. And else send string got something else, like so. Don't forget your semicolons. Okay, so let us compile this thing. Let me mount it. Okie dokie. Now, if we were to send this thing, yeah, we should get got 0, 1. Excellent. Now we need to be able to send 0. What was the next one? Oh yeah, 1f. 1f, like so. And if we were to send that, got 1f. Excellent. So yeah, that actually works as expected. That's good. Now we need to be able to read with this fucking shit. Right. Cool. So we can read this thing just fine. So that's fine. Now we actually need to be able to send stuff. So the response, so this is creating length. So this is actually going to be, where is this fucking shit? Needs to be this. So response is gonna be this. Stop it. This. So yeah, and then response 0. Yeah, then we just fucking send it back as this. So what we're doing here is we're setting everything inside this thing to 0. And then we are going to, instead of b, we're going to do, let's do x 0, x, let's do like fe or something weird like that. And then we can do for the first one, you can do ed like so. Okay. And then here, we are going to print this response. Yeah, I'm gonna print this response, maybe in hex, I don't know. Actually, let's see what it actually looks like anyway, so fuck it. Okay. But first of all, we need to compile this thing. And then I'm gonna flash, oh shit. What the heck is this thing happened? Raw heap size is undeclared. Huh. Okay, that's a new one. Okay, let me open up just another version of this, and I'm gonna search if this thing is defined anywhere. Okay, so we have raw hid.c. Oh yeah, this is our one. Okay, so this has it here, but how the fuck? Okay, so there is via. Okay, where is this thing actually defined? It's defined in USB descriptor. Huh. Interesting. Okay. Yes. Yeah, that's our one. If raw enable. Okay, well, raw is definitely enabled. Let's see, what do you include? You include report.h. That would make sense. Okay, let me try including report.h. Or actually, is that report.h or is that maybe HID descriptor.h? Fuck, I don't know. Oh yeah, it's USB descriptor.h. Okay. Oh my god. Yeah. So, what the heck? Okay, so it's USB descriptor.h is actually what it should be. Okay. Oh, Jesus. Okay. So that should work maybe. I'm not sure actually. Let's see. It might not include that file properly. Yeah, that's what I thought. Wait, what the heck? Implicit declaration of raw HID send. Why? You fucking bastards, like... Let's see. Yeah, they don't fucking tell you anything. What I'm guessing is I'll need to include... Actually, if we search for raw HID send inside here, where is this thing defined? Right. Okay, so there's some guy using here, raw HID send. Let's see, what did you include? You included raw HID. What the fuck? Hang on. The fuck? HID display, what the heck is this? Huh. Process raw HID data. Display, interesting, okay. Okay, so I'm guessing I just need this thing. I'll copy these two just in case. Jesus. Okay, probably don't need this, and I probably don't need that. It would be great if the fucking documentation was updated. Jesus. Okay, so let's try building it now. Okay. Undeclared. Okay, so we actually do need to use... fuck, where am I? We actually do need to use this. Probably. And let's try it again. Okay, that seems to have fucking... Oh, Jesus, okay. Man, life is very fucking difficult. Okay. This thing should send stuff when we send stuff to it. Yeah, so let's give that a try. Okay, yeah, so it responded in a bunch of bytes. Yeah, I mean, and here's the feed. So pretty cool that we can do this now. So yeah, it's getting a bit late. It's what is the time here? Yeah, fucking 11 o'clock. So I'm gonna go fucking to sleep. But we got, we got a good bit over the way. We got our proxy going, or this router, or whatever the fuck, and we got this thing going as well with the key codes here. So that's pretty good. So we can receive data, and it works just as expected, just with with the bytes like that, just fine. So that's good. So yeah, I actually wonder if I were to print this as bytes, what the hell would that look like? It looks identical. Okay, cool. So Python just formats this. Okay, that is fine. Right. Actually, Python, let's see. Python tree print bytes nicely. Because I want it, to be like a table or something. No, I don't want the code. Is there like a pretty print for bytes or something? Python. Yeah, byte Harry or something like that. Oh my god, what is this? Okay, do you know what? Fuck it. Fuck this shit. Okay, so yeah, that's good enough for me. Yeah, I suppose, we can parse this out later in tomorrow's video, because yeah, this is how much space we have, and it's not too much, so that is fine. Okay, so yeah, I'm going to save this because I'm running inside TMP. So right, I need to add a git commit setup for raw HID. Push this guy out there. Okay, well, anyway, we'll come back to this tomorrow, and then we should be able to actually send data between these fucking things. Yeah, unfortunately today a lot of time was spent fucking configuring Linux. God damn it, like. Oh my god. Oh Jesus. Okay. Yeah, I should actually put the references at the bottom. That I think about it. Okay, so that's fine. Yeah, so fuck it, whatever. Alright, thank you boys for watching, and I'll see you next episode. Bye bye.